little weird talk because I was asked to come and talk about new technology and how that rolls into the mining space. But I'm coming to you as a technical advisor in a hyperspectral core imaging company. So a lot of that is through the lens of that. I am a geologist, as my intro just said. I have done time as an exploration geologist. I've been an academic, and now I'm inside of Corescan as a technical advisor. So we've seen a lot about, and again, the talks, I swear we didn't talk to one another, but there's a lot of themes that are coming out. There's a tsunami of new technology, and what do we use, and when do we use it, and where do we use it? It can seem very overwhelming, and we are one of the people who, our company is one of those entities overwhelming you, and we realize that. There is a tremendous amount of data that's coming in that is super data intensive. The middle image that you see here, you've got a lot of stuff coming in from oil and gas now. I live another life in oil and gas as well, because this is used in that arena as well. So you have a lot of downhole bore imaging techniques that are starting to come into mining. They, of course, have been using that for decades in oil and gas, but it's starting to work its way into mining now. Things like CT scanning. There's a lot of people investigating that now. That's been in oil and gas for about 10 years. So there are, I will put in a little plug there because it is one of my things right now, is that miners and petroleum geologists should be speaking to each other more. Okay. So there's this huge amount of data, and what do we do with it, and how do we focus on it? Now, I'm going to be talking mainly about, through the lens of hyperspectral, but I'm going to show some examples from some other areas. So I have this sort of cheeky title, and it was really just to, right before lunch, to kind of address a few of the elephants in the room, if you will. So this first concept of a silver bullet. As geologists, we're all looking for that one, many of us are, maybe not all of us, but a lot of us are looking for that one technique that can do everything. And there are certain people who look to us at Corescan and say, well, maybe I can get rid of my core logger with doing this. The answer to that is no. But we're always looking for this. And so I put up a couple of examples, and I've picked two, and I'm not picking on them because they're actually two of my favorite techniques. But oftentimes, we try to make things do more than they probably really should. So we need to be very cognizant we use all of them together, and there are certain things that certain tools are good at and certain things that they aren't. So XRF is one. I've got a little bit of information here. You see a lot of people out there thinking, well, maybe I can get rid of assay if I use a handheld XRF or the new Minilize system. And I think that both Minilize and all of the providers of handheld XRF would go, ooh, don't do that. Because it's a tool that you're using with other types of analyses. And we all know that while XRF is extremely powerful and can do a lot of things, they're very useful, both in the field and in the core shed. There are limitations. For instance, gold. Gold can be really tough in XRF. There's a lot of overlaps with identification of elemental analysis from an XRF. There's differences between a portable XRF and something done in the lab. So as long as we recognize that we can use this, and that's great, but you just have to be careful that it isn't the silver bullet, it isn't this one thing. And I'm also putting, there's the one ring up there. We keep looking for this one ring to rule them all, and there really isn't. The next one, QuemScan. I love QuemScan, and a lot of people use QuemScan, and there's some companies that use it more than others. Again, it is a very high-tech set of analyses. It is a model, though. There is a model, there is a SIP library that is generated, and it should be generated for each deposit, and it is a model, and there's an expert analyst who is working with this data. So it is an elemental technique modeling mineralogy. So as long as you understand that and you apply it correctly, it's great. But this isn't this silver bullet. It isn't this one thing you can do, and I don't need to do anything else. I'm just going to do QuemScan, and I don't need to do anything else for my MET testing. Any of the providers of QuemScan here would tell you it actually can be difficult to do clays, for instance. Well, there's another technique that can do clays really well, and that's infrared. So you can use them together. And also this concept of, there's a lot of micro-analytical techniques that are very fine scale, but can be very difficult to scale them. We do it anyway. We'll do one QuemScan measurement for a 100-meter block model. Well, is one measurement really describing what's going on in that 100-meter cubed block model? Probably not. We know that, but we have to use something, so we use this. But are there ways to scale microanalytical techniques up? One of the ideas has been, of course, to use things like hyperspectral core imaging because it's continuous. It's got a couple 100,000 data points per meter, so it's continuous. Can we use this, create relationships between what comes out of the XRD or the XRF or the other geochemistry or the QEMScan and use that to scale up? The answer to that question, I think, is yes, and that's what a lot of our clients are in the throes of doing right now. How do we combine the continuous mineralogy with the micro limited interval sampling? So there's not one technique that's going to give you everything. It is the marriage of multiple techniques. Fake news. All right. This is the part where I say that there's a lot of people out there. It's like deja vu, Groundhog's Day, where it's 1985 again, and everybody's out there saying that you can do all of these amazing things with a satellite image, and you don't need any ground truth data, and I'm going to show you where your prophyllite is with a 30-meter pixel. No, that's not real. You're looking at a real study here, and it looks like I left off the author on this. This is John et al. From 2015. You can do amazing things with things like Aster and Worldview. You can, but you need ground truth data. You need real spectral data from the surface, whether that's from field spectroscopy, from an ASD or the old PIMAs that are still kicking around, or whether you actually train it with airborne spectroscopy. So if you want to really if you want to have a better, to know that what you're seeing on the ground is real, then you need some field spectroscopy. You need some actual infrared measurements from the ground. Then you can scale that up into your airborne or into your satellite imaging. There's no free lunch here with data. If you want tiny little pixels on the ground because there's some reason you think you need a 0.5 meter pixel on the ground, maybe you're trying to scan over a leach pad or something like that, rather than wide area exploration, that's cool, but you're going to give up signal to noise, you're giving up bandwidth, how fat your bands are, because that's how it allows you to actually absolutely identify mineralogy, and you're giving up wide area coverage for that. Now, if you're doing wide area exploration, you're better off going with a system that has the thinner bands, the higher signal to noise, but some slightly larger pixels because you're trying to cover large areas and you can do it faster. So you have to know what to ask, and this is now the other half of the talk. So the real theme here is you have to ask a specific question. Have a question in mind. When you know what it is exactly that you're trying to do, then you can go to the providers and ask them, what is your spectral resolution? What is your spatial resolution? What is your swath width? What's your signal to noise? And do you calibrate? You need to ask people that. And how are you calibrating? Because this is a whole ecosystem here. We're here from a core imaging company, but all of these spectral techniques should talk to each other if people are calibrating correctly. So you can use TerraSpec, halos, high loggers, high maps, drones. They should all speak to one another if everybody's calibrating right and we're all holding hands and doing this together. But you need to ask your vendors this. So finally, myth. This one I'm going to touch on very briefly. You could do a whole talk on this. Everybody's talking about AI. The machines are coming and they're going to do all of our jobs. So there's sort of this extreme right now going on where you say, nope, the field geologist can do everything that I need to do. And then you have the people who say, nope, let's hand it over to the machines. It's all about machine learning and AI. Obviously, the answer is somewhere in between the two here. We do a lot of really great work with AI. We have a statistically overdetermined data set with Corescan. We have hundreds of millions of data points. It lends itself well. So I love the machine learning AI-based work that we're doing. But it is trash without a geological expert, a domaining expert, helping to train the machine. We're not there yet. This isn't going on its own. So obviously, you knew the answer would be that I would say that it is both a savior and a distraction. The increasing cost of mining makes our costs, whether it's CapEx or it's societal, that's getting tougher. It's getting harder to find things. Doug showed a great plot where he said all the reasons why we haven't developed certain mines. So that's getting tough. And new technology can help us shrink that and help us to make potentially uneconomic mines economic, potentially. This is a great law. I'll call it a law down here at the bottom, not like a physics law, but it's called Amara's law, which says that we tend to overestimate the effect of a technology in the short run, and underestimate its value in the long run, which kind of speaks to a little bit of what Kevin was talking about. So the initial phase, we get really excited about something. It's going to solve all of our problems. And then it kind of bums us out because it doesn't solve all the problems. And it wasn't the silver bullet we hoped. But we're underestimating what it does for us in the long term. So in this case, thinking about what it does in actually estimating what the mind can do in the future, what its problems are going to be, the geometallurgical issues, process, environmental, et cetera. So people might have seen this curve. Business and innovators and futurists love to show this plot. It comes out of the Gartner Group, which is the think tank, and they call it the hype cycle curve. And you start out here where you have some type of a trigger. Sometimes that's just a company coming up with a new idea for something. Sometimes it's an operator saying, I really wish you could do this. And so you get this initial trigger, and everybody gets really excited. And you get this really high phase of visibility, and everybody's talking about it. You know what's right here right now? Drones. The drone frenzy of 2018, right? Everybody's talking about drones. So we're here with drones. Somewhere you get to this peak where you get this really heightened expectation of all the problems it's going to solve. And then, as I said, it doesn't, because nothing is a silver bullet. And then we crash into the trough of disillusionment, or the pit of despair, as I sometimes call it, where everybody's wallowing around down here, trying to figure out how to use it. Oh, it didn't do what I wanted it to do. Well, it did that. And so there's all sorts of hand-wringing going on right here. And then slowly, people just pushing forward, marrying it with other techniques, it starts to work its way back up to where you get into this plateau of productivity. This is where it actually fully gets integrated into a system, or into a mine, or whatever it is whatever technology it is that you're doing. So this is I run into this a lot in my world with all of my different clients. They usually self-identify here as either an early adopter. So an early adopter will come in, and they come in right at the beginning. And I won't name names here except for the very first one I'll name, which was our early adopter, which was Newcrest. So Newcrest came in on practically day one. And they have been with us the entire time. And I'll mention just what that has brought for them. Then you have fast followers. So these are the folks who come in behind someone like Newcrest, recognize what they're doing, and go, okay, we're going to do that. We're going to wait a little bit, see if it holds on, and then we'll jump on. And so that comes in here. So they don't get in right at the beginning, but they come in pretty soon. Then you get what you would call the followers. The followers usually jump in right when it's hottest. And so you jump in, you go, okay, I'm going to do this. The lemmings. Everybody's like, okay, there's enough people here. I'm not going to look weird if I do it, so I'm going to do it. So they come in, and they're riding in with us, and that's good. Now you have some folks, which is a little rather dubious to call yourself this, but I did have an operator call themselves a slow follower. So they're going to wait until it gets kind of bad, and then sort of go, okay, I see everything that could possibly go wrong. Now I'm going. And then finally, this is my turn, the last call crew, and you know who you are. These are the people who wait until the very end. They wait till 5 other companies already have it in the process, and then they jump in. I'm not going to name names. This is usually the really big companies. They're going to wait until the end. The one comment I say, because I could probably give a whole talk on this, but the one thing I'll say here is that if you're an early adopter, you say, well, what do you get by waiting to the end or starting really early? The DNA of Corescan is made up of Newcrest telling us ideas. You should make the product look like this. It should look like that, this, that, this. There's so much of what Newcrest envisioned inside of Corescan because they got in early. And there's a few other companies who got in with us early as well. So you're able to really guide and mold what a technology becomes if you get in early. If you wait to the end, you save money. However, do you save money? Because you've lost out on the technological advantage of getting in earlier. Now, if you're a big company, it probably doesn't matter, which is why they do this. So why do you do this? So the last piece here, why do you use new technology? So we're talking about new technology. Why would you use it? Well, just because. No. We had some year-end money. Why not give it a go? No. Well, we heard tech was doing it. No, not a good reason to do it. So what's the reason to do it? It's simple. I have to answer a very specific question, and I need somebody to help me solve my problem and know what that specific question is. So here's some ideas of questions that we've actually gotten. Can hyperspectral imaging see biotite? Okay, that's an okay question, but that wasn't what they were really asking. What they're really asking is what Carrie was talking about. Can you see my potassic? We want to map my potassic. So that is a more specific question. What can LIBS or QuemScan or XRF or Corescan tell me? Okay, that's an okay question back in the early adopter phase, but that's not super helpful 10 years in. Because what people are really saying is they have a real question. They're saying, hey, can you see lithium in a white mica? This is a great question. I suspect I have talc. Can technique A see it? If so, how much do I have? Because that's a specific question that allows us to give a specific, to assess and give a specific result. And then you can assess us, and you can assess the technique. So I'm going to give you a couple of examples of that to finish off. So here is case study one. So I'm going to show you one where it wasn't a great question, and then I'm going to show you a couple that were good questions. So here one, and to be fair, this was a project that is quite old now. It's about 5 years old. But there was sort of this general question, can you map texture in my core? And so, yeah, we can. And we can do it really in a really detailed way, not only pulling out the mineralogy, but telling you the paragenesis, the distribution of these minerals, and then, for instance, looking at different, so you've got actually 2 sets of sericitic veins coming in here. So yeah, of course we could do that. But their real question was not that. Their real question was, we have a met problem. We have a clay problem. And we don't really know where it is and why and where and what's going on here. That would have been more helpful to have known from the beginning. Because, in fact, and this also goes back to what Carrie was showing, this was a deposit that actually has sort of out of character, if you will, for a porphyry in this district, a deep, late stage, theoretically, that was what it was theorized to be, sort of an illite smectite population at depth. And in fact, it ends up going right along with their potassic zone. So while we can map the biotite and the chlorate, because the chlorates were coming in and altering the biotite, as Carrie was mentioning, we could see that, so we could see the potassic. In fact, the better map of their potassic zone was this illite smectite alteration of the feldspars themselves. And that turned out to be a wonderful correlation to their copper grade, although not so wonderful, right? Because now you have sort of the identification of the, one of the met problems. So the problem here was that this wasn't even in the logging codes. They weren't even logging this. It was not identified. It was very fine-grained. Not bad geologists, just very fine-grained and difficult to log. It was very suspect, thus, to the geology team, and here's where I'm going to, where Sebastian mentioned this morning, you sort of have this vision of what you are, where you are and what this is, and sometimes it can be hard to bump people out of that and say, hey, it's cool, it's okay. But this just might be a slightly different model that we're giving you. It's a slightly different mineralogy. We're still seeing the potassic. We're still tracking your copper. But it's just, we're going to need to call this something else. And in the end, we also failed our client because we backed off. We said, okay, we don't know your deposit. You guys are the experts, so we kind of backed off. We probably should have kept pushing a little longer on this. This is a lot here, but all I'm going to point out here is that the other thing is that we now fully understand a true disruption. This phrase gets thrown around a lot, technology disruption. This is a true disruption, particularly, not as much in the exploration phase where you start early, like Kevin was talking about. When you come into a mine that's been operating for 10 years, 20 years, 30 years, and you say, hey guys, just letting you know we're going to completely change your logging code. That doesn't go over so well. That costs time and money to come in and completely change a logging code like that. Does it mean we shouldn't do it? No, but I understand, and I think we all understand just how disruptive it is to bring in something like Corescan down here after you are already mining. It's very disruptive. So now just a couple of questions of where it worked quite well. Some of you may have seen this plot before. This one was very specific. This was an explorer, an early stage explorer, who came to us and said, I think we have talc. We have a little bit of ASD data. We've got talc, but how much do we have and how is it distributed and can you characterize it at all? Well, that was a really good question because we could go in, do this and see and tell them, you do have talc. It's pervasive, although in some parts it is going along with some of the weaker vein populations. But good news, it's super crystalline. So that probably helps you out a little bit here, thinking about in the future how they think about this project and how they go to try to sell it or JV it in with someone, which is kind of what Kevin was also talking about. I'm going to skip the lithium one if you want to come and talk, because I want to make sure I get my conclusions in here, but we have another, this is another good example of using a really specific question about lithium contents. So I want to end by showing just the 3 main points here of what are the barriers to this and what are some possible solutions. So the first barrier, cost. I love that Corescan's a giant rat. But people say, oh, it's cost, right? Funding for the survey is usually easy to get, but then which cost center does it go? Does it go into exploration? But then exploration gets mad when the mine starts using it, and they're like, why am I paying for this? So how do you do this? And how do you secure funding over a long period of time with the budgets going up and down, and all of a sudden mining isn't cool anymore? And how do you continue to fund innovation like that? As well as personnel. You can buy an instrument, but somehow you need to fund the person who's going to be watching over it and being the champion. So longer budget cycles, that's not going to happen. A lot of our clients have used these director or executive level budgets where they sort of sit on top of things and they're able to fund things for longer term. So that's something to think about. Procurement, this is not very exciting but really important. New technology is not a widget that you can buy. It's not a set of tires. So that's sometimes hard to convey to your procurement team, that you can just buy something, but particularly in the early years, vendors and services are really different from one another. So you need to try to get in there earlier to help procurement help you buy the right system or buy the right service. A technical champion involved in purchase is great. It's not usually allowed. So if you get some really specific questions, help them write that request for proposal. And also think about trials. Oftentimes trials, the initial trials that companies like us do, they sit below procurement level. You know, they're 5K or something like that. You don't always have to go through procurement. Expertise, and then the final piece here is expertise, which that's what I want to end on, is that the hardest part of bringing a new technology in is getting the expertise in your company in order to help you use it. So in-house, generally you don't have the staff to be able to do that. That's why it's new tech. And usually what happens is someone gets marked, even though they already have 500 other things to do, and they say, you're going to do Corescan now too. Guess what? Then it doesn't happen, because they've already got too many other things to do. You could go with consultants. Consultants are very practical, but it's also hard to source consultants who know about new technologies. Okay in the short term, but they're bloody expensive. So if you're talking about mid to long term, you don't want to be having 10-year-long consultants. Academia and government, super important part of this. Their role in this is that it is a great investment in the long-term health of a new technology, and we should all be funding this. Corescan helps to fund and advise over 20 to 25 different students at any one time. So we should be investing in this, but they do have longer timescales. We all know that. And finally, vendors. We're highly technical. We're key personnel. This isn't 30 years ago. The entire sales team of Corescan is all PhD and master's level geologists. Use us. Use us. That's what we're here for. We are your helpers. Until we aren't. We all are selling something. So you need to be asking your vendors the hard questions. And if they can't answer your questions and they don't know the specifications, don't use them. And I'll skip over confirmation bias, although it's my favorite thing ever. And I'll end finally with the future here. These are some of the ideas of the things that I think are actually the future innovations in mining: multivariate analysis, machine learning driven analysis, instruments with multiple different types of measurement tools, so the tricorder paradigm, and real-time production. And then I'll end with saying that, again, you're not getting rid of us anytime soon. All of these technologies, everything that I've talked about, it is reliant on geologists and the expert people to help teach the machine, because machines are dumb without humans.